Hey everyone, welcome to 7.3 Part 2, Integrals involving powers of secant and tangent. One thing I want to remind you of, tangent squared x plus 1 equals secant squared x. That's going to be helpful as far as being able to convert tangents to secants and vice versa, so that way you can get whatever you want. On page 493, there are a whole bunch of examples and when you're given a cube or a square or something like that, what should you do to kind of figure out some of these integrals? So I recommend that you go to page 493 and look at those four, and then we'll actually do one with the fifth one, which is converting to cosine and sine. So here we go. Here's our first example, integral of tangent cubed over the square root of secant x dx. The first thing you probably want to do is we're just going to rewrite this as the integral of secant x to the negative 1/2 tangent cubed x dx. Alright, and so when we look at this, if I want to get something like, if I want to have it all in terms of secant, I want to make sure that I have a secant tangent. That way when I do the substitution method, then I should be able to do that. So I want to be able to get everything in terms of secant, and I want to be left with the secant tangent left over, right? So I have tangent squared, which means I can probably change that to a secant squared, and I'll be having just one tangent left. So what I'm going to do is I'm just going to rewrite this as the integral of secant x to the negative 1/2, there we go, times tangent squared x times tangent x dx. Okay, that means I just broke up this into two parts. Alright, not bad. So now I have to get something into like a secant x and all that kind of stuff. So here's what I'm going to do next. What I'm going to do next is I'm going to try and get the secant that way, the secant x that way, because I have all multiplication. I'm going to try and get that thing. I want to try and get this out of the way. That way I have it all set up. So I'm actually going to pull out a secant x from here. So if I take out one secant x, that's really going to be the integral of secant x to the negative 3/2. Oh, hold on. Let's try that again. Let's just undo this here. There we go. Secant to the negative 3/2x tangent squared x, and then I've got a secant x and tangent x dx. Okay, so really what happened here? Well, I took something from here and I took one full secant out, which means I have to take this down one power, and I'll have secant to the negative 3/2 tangent squared secant x tangent x dx. So now really this whole thing should be my du, right? So now we know, hey, I've got du right here. I just have to make sure that I have secant x in here. So now let's see, what can I do from here? Well, I know that I need all secants if I want to be able to use this for my du. So I'm going to change this tangent squared to secant x minus 1. So I've got the integral, let's just put these equal signs in here, the integral of secant to the negative 3/2x, and then I'm going to multiply that by secant squared x minus 1 times secant x tan x dx. Okay, so now what I'm going to do is I'm going to distribute this secant to the negative 3/2, to both of them, and I should end up with the integral of negative 3/2, and that one is going to be secant to the 1/2 x, and then this is going to be minus secant to the negative 3/2 x, and I'm going to put all that in parentheses, and I'm going to say that's going to be secant x tan x dx. Okay, so now what I'm going to do is, let's just move me up here. We don't need this stuff anymore. We are going to say that, let's set u equal to secant x, and that means du is going to equal tan x secant x dx. Okay, so now I can write this whole thing then goes to be the integral of u to the 1/2 minus u to the negative 3/2 du. Alright, and then what we get from there, we should be able to take this and say that's going to be 3/2, blah, 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 blah. I'm going to save some time and say that's going to be just 2/3 of secant to the 3/2 x plus 2 secant to the negative 1/2 x plus c, and that would be this first one. That's a lot of extra work here. They're not always going to be this tough, but that is the first one. Alright, I think I'll actually make this into 2 videos, and we'll just do this for the rest of them will be a whole new one.